Hello and welcome to this Math Bay video on how to find area of a triangle using sine. We're going to be looking at triangles for which we know two sides and an included angle. For instance, if I know in this triangle the measure of angle A, the length of side little c, and the length of side little b, and I wanted to find the area, the first place I would start is that area is 1/2 base times height. I know the base of the triangle, it's C, but I don't know the height. If this is the base and I drop an altitude, I can use basic trig with this angle, angle A, to find the height, knowing that the sine of angle A is equal to the opposite over the hypotenuse in this little right triangle right here. Then I can solve for h by cross multiplying and get h equals b sine A, which can be substituted for h right up here, b sine A. So I have that the area of the triangle is 1/2 times b times c times sine of angle A, the angle included between b and c. This works any way you turn the triangle. I take the same triangle and I know angle B instead of angle A, and side C and side A, the two sides around it. And I wanted to find the area with C as the base again. Base times height, 1/2 times the base of C times the height of, we don't know. So now I'm going to find the height using this right triangle. I know that the sine of B is equal to the opposite, which is the height, over the hypotenuse. So cross multiplying this proportion, h is equal to a sine b. Substituting that in, 1/2 times c times a sine b, or 1/2 az sine of b. So now I have two expressions that I could use to find the area of the triangle. Still turning the triangle one more way, and in this version I'll know angle C and its two surrounding sides that it's included between B and A. I could use either one as the base, so I'm going to look at it with A as the base. Drop an altitude with A as the base, so I'm doing 1/2 base times height for the area of the triangle. The base is A, the height is, we don't know. And remember, we're assuming that we know the values of the angle and the two surrounding sides. So I'm going to set up a trig function in this right triangle to find the height. The sine of angle C is equal to the opposite over the hypotenuse, h over b. So h equals b sine of c. Take that and substitute it in. I get a new expression that the area is 1/2 times a, and in for h is going b sine c. So whether I know b and c and its included side, or c and a and its included side, or B and A and its included side, I can find the area of the triangle by doing 1/2 times the side length times the side length times the sine of the included angle between those sides. And all this comes from 1/2 times base times height. So we can find the area of a triangle for which we are given SAS. SAS ensures a unique triangle, which will have a unique area. So let's see how we can use this. Here's an example in which we have two sides in the included angle. Now I could work to find the height, or I can use my new formula that says it's 1/2 for the area of the triangle times the length of the side, 5.3 centimeters, times the length of the side, 7.1 centimeters, times the sine of the included angle, sine 47. At this point, I'll take my calculator and do 1/2 times side times sine of the included angle, and hit enter. Sine 47, 13.76, about 13.8. So the area is approximately 13.8 centimeters squared. Looking at another similar example, the area of the triangle is 1/2 times side times the length of another side times the sine of the included angle. And we can do the sine of 110 because of the fact that we know that the sine in quadrant 2 on our unit circle, if we remember, 110 is more than 90. This is where 110 degrees is. The sine of that angle is the same as the sine of the reference angle of 70, so I could just as easily put sine 70 right here and get the same answer. The sine is the y-coordinate, and sine is positive. Sine will be opposite over hypotenuse, y over 1. It's still positive in quadrant 2. So now I will do 1/2 times the length of the sides multiplied times sine of the included angle, 1/2 times 11 times 8 times sine of 110, and I get 41.3. Notice I'm saying approximately because we are rounding here. And that's the area of that obtuse triangle. Two more, a little bit different than the previous two, a little wordy, where we have to create our own picture. We have a triangle with side lengths of 5 and 6 and an included angle of 30. Now in this one, I noticed that 30 because it is a special right angle, which means I should be able to do this one in simplest radical form and not have to grab my calculator so much. So if I'm going to draw a picture, just to give myself a little idea of here, 5, 6, and the included angle of 30. So we would do for the area of this triangle, 1/2 times the length of the side, times the length of the side, times the sine of the included angle. I'm going to go ahead and get this sine of 30 rather than as a decimal, as a simplest radical form using my unit circle. Here's 30 degrees on a unit circle. Okay, the short leg, which is the sine value because it's opposite over hypotenuse, is going to be 1/2, as we already discovered in our previous video. So it's half of the hypotenuse. So the sine is 1/2 over 1, or 1/2. So the sine of 30 is 1/2. So let's see what happens here. Okay. Oh, I forgot to put in my 1/2 for sine of 30. We don't need that degree symbol anymore. Okay, see, 1/2 times 1/2 will give me 1/4, and 5 times 6 is 30. So I have 30 over 4 meters squared, which is about 7.5. Well, not about, exactly 7.5. So that is the area of that triangle. Didn't even need a calculator. All right, this next one, we have triangle XYZ. Angle X is 135. That's a big angle. And XY is 7, while XC is 4. I see that 135. I remember it from all those special right triangles on the unit circle. So I know that I can get a special trig ratio number for that as well and not have to run for the calculator on this one. The area of the triangle is 1/2 times side times side times sine of the included angle. The sine of 135 is equal to the y coordinate at 135. Here's 135. All right, unit circle 1. And this is negative square root of 2 over 2 and positive square root of 2 over 2. So the sine is square root of 2 over 2. So the area is 1/2 times 7 times 4 times square root of 2 over 2. If I multiply my fractions together, I get square root of 2 over 4. And 7 times 4 is 28. 28 divided by 4 is 7. So my area is 7 square root of 2 inches squared for that one. And that is how you can use area with sine in any side angle side situation.